Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal, and in this lecture we are going to study boat and stream. So in this lecture we are going to study the concept of boat and stream, in which we are going to start with speed of boat or boatman, and then we will move to speed of stream slash current, and later we will study downstream speed, upstream speed, and then we will study speed in still water, rate of stream, time, distance, and speed relations. So what kind of questions that are asked in this topic? So the question can come up like find the speed of boat and stream, or find the time taken, find the distance, relative speed question. So these are some type of questions that can be asked based on this topic. So let's start. So the concept of stream in mathematics pertains to questions involving the motion of boat in flowing river or stream. The key to solving these questions is understanding the relationship between the speed of boat in still water, the speed of stream, that is current, and the effective speed of boat when moving upstream or downstream. So there are a lot of uh, terms that seems very new, correct? So first of all, we must discuss what are those: speed of stream, speed of boat, upstream, downstream. So we are going to study all these things in detail. So speed of boat and stream. The speed of boat slash boatman in still water. It is denoted by U, and this is the speed of the boat when the water is still and not flowing. Okay, so the water is not moving, it is still on its, and when we calculate the speed of boat, in that case it is called as speed of boat and it is denoted by U. And speed of stream or current, which is denoted by V, this is the speed at which stream or river flows. So that's the speed of the river flow. So what is a downstream speed? So it is U plus V. So when the boat is moving in the same direction as the stream, its effective speed increases because it's being added by the current. So the downstream speed is sum of boat's speed in still water and the speed of the stream. So the downstream is given by U plus V. So downstream speed is nothing but the speed when the boat is moving in the direction of the stream. Suppose it is going from left to right, then the boat is also going left to right, then we will say it is in the downstream with the flow of the river. And when do we say it's upstream speed? It is calculated as U minus V. And when the boat is moving against the direction of the speed, in that case, its effective speed decreases because it's being opposed by the current. The upstream speed is the difference between the boat speed in the still water and the speed of the stream. So the upstream is given by U minus V. Okay. So what are different type of speeds? So speed in still water. So if the downstream speed is U kilometer per hour and the upstream speed is V kilometer per hour, then the speed in still water will be U plus V upon 2 kilometer per hour. The rate of stream, if the downstream speed is U kilometer per hour and the upstream speed is V kilometer per hour, in that case the rate of stream is U minus V upon 2 kilometer per hour. So for now, just see whatever I'm trying to explain and try to remember the formulas. Don't worry, we will solve problems based on these and you will understand all the things very clearly. So it's time for questions. A man can row upstream at 7 kilometer per hour and downstream at 10 kilometer per hour. Find man's rate in still water and the rate of the current. Okay, so let us see the solution. Rate in still water is given by 10 plus 7 upon 2. So we have already seen the formulas. How do we do that? So the formulas are being used here. So we will have 17 upon 2, that is 8.5 kilometer per hour. And the rate of the current is 10 minus 7 upon 2 kilometer per hour. So it is 1.5 kilometer per hour. So in the first case, we added up the speed of upstream and downstream to obtain the still water speed. And in the second case, to obtain the rate of current, we took the difference and divided by 2. So let us move ahead to question number 2. So a man takes 3 hours 45 minutes to row a boat 15 kilometer downstream of a river and 2 hours 30 minutes to cover distance 5 kilometer upstream. So when the man is going downstream, he covers 15 kilometers in 3 hours 45 minutes, and when the man is going upstream, he covers 5 kilometers in 2 hours 30 minutes. So find the speed of the river current in kilometer per hour. So rate of downstream is given by distance upon time. So the distance traveled by him is 15 and the time taken by him is 3 of 3/4. So it will be 15 times of 4 upon 15. So that is 4 kilometer per hour. So rate of upstream is 5 upon 2 of 1 half. So which is equal to 5 times of 2 upon half, 2 upon 5. So that is 2 kilometer per hour. So the speed of the current will be given by 1 upon 2 times 4 minus 2, that is 1 kilometer per hour. So the correct option here is option A. Now, question number 3. Rashmi can row 18 kilometer per hour in still water. So the still water speed is given to us. She finds that it takes her just 3 times as long to row up as to row down the stream. So what is the speed in kilometer per hour of the stream? So if the speed of the boat and the stream be u kilometer per hour and v kilometer per hour respectively, then the upstream speed is going to be u minus v kilometer per hour. Downstream speed is going to be u plus v kilometer per hour. And the speed of the boat u is 18 kilometer per hour. So let the speed of stream be v kilometer per hour and the distance be d kilometer. So let the time taken to cover d kilometer distance in upstream be 3t. So we have taken some assumptions and let's now try to solve. Time taken to cover d kilometer distance in downstream is t hours and upstream speed is 18 minus v kilometer per hour and downstream speed will be 18 plus v kilometer per hour. So according to the question, 3t times of 18 minus v equal to t times of 18 plus v. So which is equal to t times get cancelled and we will have 4v equal to 36 and v will be 9 kilometer per hour. So the correct option here is option C, that is 9 kilometer per hour. Moving ahead to problem number 4. A man can row 7.5 kilometer per hour in still water. If in a river running at 1.5 kilometer an hour, it takes him 50 minutes to row to a place and back. How far off is the place? So the speed of boat in still water is u, that is 7.5 kilometer per hour. Speed of stream v is 1.5 kilometer per hour. So let d be the distance. So the speed in downstream is u plus v equal to 7.5 plus 1.5 equal to 9 kilometer per hour. So the speed in upstream is u minus v, that is 6 kilometer per hour. So the total time taken is equal to total time in upstream plus time in downstream. So total time is 50 minutes, which is equal to d upon u minus v plus d upon u plus v. Speed equal to distance upon time. That formula is being used here. So time will be equal to distance upon speed. That is exactly what is written here. So on simplifying, we will have 50 upon 60 equal to d upon 6 plus d upon 9. So it will be 5 upon 6 equal to 3d plus 2d upon 18. So on simplifying, we will have d equal to 3. So that means the total distance is 3 kilometers. So the correct option here will be option number B. Now, problem number 5. In a stream running at 2 km per hour, a motorboat goes 10 km upstream and back again to starting point in 55 minutes. Find the speed of the motorboat in still water. So let the speed of motorboat in still water be u km per hour. Speed of downstream is equal to u plus 2 km per hour. So the speed upstream is going to be u minus 2 km per hour. So therefore, 10 upon u minus 2 plus 10 upon u plus 2 is equal to 50 upon 60. So on simplifying, you will have a quadratic equation that is 11u square minus 240u minus 44 equal to 0. So doing the middle term split here, you will have u minus 22 times 11u plus 2 equal to 0, which is equal to u equal to 22 km per hour. So the correct option here will be option number C. Now, problem number 6. A man can row 40 km upstreams and 55 km downstreams in 13 hours. So there is a man who is rowing a boat, and if he goes upstream, he covers 40 kilometers in 13 hours. And if he goes downstream, he covers 55 kilometers in 13 hours. So also he can row 30 kilometers upstream and 44 kilometers downstream in 10 hours. So find the speed of the man in still water. So let downstream speed be x kilometer per hour and upstream speed be y kilometer per hour. So according to the question, so the again speed equal to distance upon time. So 40 upon y plus 55 upon x equal to 13, and this implies that 120 upon y plus 165 upon x equal to 39. So we name this as equation number 1. So also 30 upon y plus 44 upon x equal to 10. So one more information was given to us in the question. Here two information is given. This is the first information and this is the second information. So these two are going to frame two different equations in x and y, and we can easily solve them to obtain the unique value of x and y. So the second equation that turns out to be 120 upon y plus 176 upon x equal to 40. So now taking a difference 2 minus 1, we get 11 upon x equal to 1. So x is going to be 11. And from 1, we get, substituting the value of x in equation number 1, it will be 120 upon y plus 165 upon 11 equal to 39. So this is going to be y equal to 5. So therefore, the speed of man in still water is equal to 11 plus 5 upon 2 equal to 8 km per hour. Therefore, the speed of current is 11 minus 5 upon 2, that is 3 km per hour. So the correct option here is going to be option number C, that is. Now, moving to problem number 7. In 1 hour, a boat goes 11 km along the stream and 5 km against the stream. So what is the speed of the boat in still waters? Again, we have to find the speed of boat in still water. So the speed of downstream is equal to 11 km per hour and speed of upstream is equal to 5 km per hour. So thus the speed of boat in still water is 11 plus 5 upon 2, that is 8 km per hour. So the correct option here will be option number C, 8 km per hour. Now, moving to problem number 8. A boat running downstream covers a distance of 16 km in 2 hours, while for covering the same distance upstream, it takes 4 hours. That means if the boat have to cover the 16 km distance in upstream, the boat will take 4 hours. That means double time. It's going to take double time. So what is the speed of the boat in still water? Again, so we have to find boat speed of the boat in still water. So rate downstream is equal to 16 upon 2 km per hour. So it is going to be 8 km per hour. So the rate upstream is equal to 16 upon 4 km per hour equal to 4 km per hour. So the speed in still water is 8 plus 4 upon 2 km per hour. That is 6 km per hour. So the correct option here is option number B. Now, moving on to problem number 9. A boatman goes 2 km against the current of the stream in 1 hour and goes 1 kilometer along the current in 10 minutes. So how long it will take to go 5 kilometer in still water? So the speed of upstream is 2 kilometer per hour. Speed of downstream is 1 into 60 upon 10 kilometer per hour, that is 6 kilometer per hour. And the speed of boatman is 2 plus 6 upon 2, 4 kilometer per hour. So the time taken by the boatman to go 5 kilometers in still water will be 5 upon 4 hours. So this implies that 1 hour plus 1 upon 4 times 60 minutes. So 1 hour 15 minutes. Therefore, the boatman will take 1 hour 15 minutes to go 5 kilometers in still water. So the correct option here will be option number C, 1 hour 15 minutes. Now, a man can row 3/4 of a kilometers against stream in 11 of 1/4 minutes and return in 7 of 1/2 minutes. So find the speed in kilometer per hour of the man in still water. So the rate upstream is equal to 750 upon 675 meter per second. That is equal to 10 upon 9 meter per second. So the rate of downstream is equal to 750 upon 450 meter per second. That is equal to 5 upon 3 meter per second. So the rate in still water will be 1 upon 2 into 10 upon 9 plus 5 upon 3 meter per second. So the 25 upon 18 meter per second, so it is going to be 5 kilometer per hour. That is option number D. Moving on to 11th problem. A man's speed with current is 15 km per hour and the speed of the current is 2.5 km per hour. Find the man's speed against the current. So with the current speed is given to us, current speed is given to us. So what if he goes against the current? What if he flows, he tries to go against the current, then what will be his speed? So man's speed with current is 15 km per hour. Speed of current is 2.5 km per hour. So the speed of upstream is equal to speed in still water minus speed of stream. So the man's rate in still water will be 12.5 km per hour. So man's rate against the current will be 12.5 minus 2.5 km per hour, that is 10 km per hour. Therefore, the speed of man's speed against the current is 10 km per hour. That is the option number C. So the correct option here is option number C. Moving on to problem number 12. A boat can travel with speed of 13 km per hour in still water. If the speed of stream is 4 km per hour, find the time taken by the boat to go 68 km downstream. So the speed downstream is equal to 13 plus 4 km per hour, that is 17 km per hour. Therefore, the time taken to travel 68 km downstream will be 68 upon 17 hours, which is 4 hours. So it is option number C, 4 hours. Question number 13. A man can row 5 km per hour in still water. If the velocity of current is 1 km per hour and it takes him 1 hour to row place and come back, how far is the place? So the speed of boat in still water is 5 km per hour. So speed of current will be 1 km per hour. Total time taken is 1 hour. So Speed of upstream we have is 5 minus 1, that is 4 km per hour. And also the speed of downstream will be 5 plus 1, that is 6 km per hour. So let us suppose the distance be d kilometers, then the time taken to travel upstream is d upon 4 and time taken to travel downstream is d upon 6. So according to question, we have d upon 4 plus d upon 6 equal to 1. So on simplifying, we will have 5d equal to 12, that is d equal to 2.4. So the correct option here is option number A, 2.4 kilometers. A motorboat whose speed is 15 km per hour in still water goes 30 km downstream and comes back in total 4 hours 30 minutes. Determine the speed in km per hour of the stream. So the speed of motorboat is 15 km per hour in the still water. The total time to go 30 km downstream and come back in 4 hours 30 minutes. So the downstream is going to be speed of boat in still water plus the speed of stream. So the upstream will be speed of boat in still water minus speed of stream. So these are the formula that we are going to use. So let the speed of stream be V. The total time taken is 4 hours. So the total time is 4 hours plus 30 upon 60 equal to 9 upon 2 hours. So we have 30 upon 15 plus V plus 30 upon 15 minus V equal to 9 upon 2. So 1 upon 15 plus V plus 1 upon 15 minus V. So that will be 9 upon 60. So that is 30 upon 15 square minus V square equal to 3 upon 20. So the correct, so 225 minus V square 2 equal to 200. And on simplification, you will get V equal to 5 km per hour. So the speed of stream is 5 km per hour. So the correct option here will be option number B. Moving to problem number 15. A boat takes 90 minutes less to travel 36 miles downstream than to travel the same distance upstream. If the speed of boat in the still water is 10 miles per hour, then the speed of the stream is. To let the speed of stream be v miles per hour, then downstream speed will be 10 plus v miles per hour, correct? And upstream speed will be 10 minus v miles per hour. So according to question, 36 upon 10 minus v minus 36 upon 10 plus v is equal to 90 upon 60. So 72v into 60 equal to 90 into 100 minus v square. So v square plus 48v plus 100 equal to 0. So we have a quadratic equation that we can solve to obtain the value of v. So doing the middle term split here, we will have v equal to 2 miles per hour. So the correct option here is option number A, 2 miles per hour. Moving to problem number 16. A boat covers 24 km upstream and 36 km downstream in 6 hours. While it covers 36 km upstream and 24 km downstream in 6:01 half hours, what is the speed of the current? So let the downstream speed be x km per hour and upstream speed be y km per hour. So according to question, 24 upon y plus 36 upon x is equal to 6 and 72 upon x plus 48 upon y will be 12. So we have just multiplied 2 in the equation. So also we have 36 upon y plus 24 upon x equal to 6 of 1 half. So this implies that 72 upon x plus 108y equal to 39 by 2. So we have two equations now which can be solved to obtain an exact value of x and y. So from 2 minus 1 we get 60 upon y equal to 15 upon 2, that is y equal to 8 km per hour. And if you substitute the value in 1, we get 72 upon x plus 48 upon 8 equal to 12. So x is going to be 12. Okay. So therefore, the speed of current is 12 minus 8 upon 2, that is 2 km per hour. So the correct option here will be option number C. So that would be all for this lecture. And I'll see you in the next lecture with few more problems on previous year questions. Thank you very much.